Okay, gonna continue this now. Pause notes. Looking at polynomials. At a time. That sounds sensible. Okay. Okay, so in descending powers of x. So 4x cubed plus 5x squared plus 12x plus 1. All right. Next up, in descending powers of z as well, I'll combine 4z to the 6 and negative 10z to the 6 to get negative 6z to the 6. Then plus 4z squared. Then plus 2z and minus 8. Oh dear. I didn't read it carefully. It says that I am to subtract this polynomial from this one. All right, so paying attention. Negative 14z to the 6 plus 10z squared minus 2z minus 8. Next up, subtract this polynomial from this one in descending powers of x. So it should begin x to the 4, followed by 7x cubed, followed by 3x squared, then negative 19x, then negative 9. Expanding this, and now this. Okay, so check. Correct. 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 Okay, next. All right, so first will come 3w to the power of 4. Then a w cubed. Then a 6w squared. and a single w. Here, 16x to the 12 minus 12 plus 12, so they cancel out. This is the difference of two squares pattern. So minus 9x squared right there. For this one, first square it, then triple it. So when I square it, my first term will be, my highest power of y will be 16y to the 6. 16y to the 6. And I triple that, and I get 48y to the 6. My next term will be negative 80y cubed, and I triple that, and I get negative 240y cubed. Finally, I'll get 100, which when I triple is 300. Now, one quadratic multiplied by another. In our mind, we visualize it as a 3 by 3 table, and we read diagonally. Okay, so it'll go 3x to the 4, and then minus 5x cubed. Okay, beg your pardon, these pages aren't loading, even though they're just simple pages. Okay, then minus 6, minus 14, minus 21. Okay, and now 16 minus 7 is 9. And finally, 14. And next, we are to square this out, then triple it, and then subtract it from that. So, can I do this mentally without mistakes? We'll see. So first, when I square this out, I'm going to have x squared, which is x to the 4. And I triple that and I get 3x to the 4. So that will be my leading term. Then I'm going to have 2x squared, which becomes 6x squared, which deducted from that will turn it into negative 15x squared. Finally, I'm going to have just 1, which tripled is 3, and subtracted from that is negative 7. Everything else will be left alone. So 6x cubed there, and negative 13x there. And now we check. Correct. 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 Okay. Next up, I'm going to try factoring polynomials. I'm up for it. Actually, maybe I should like save this. I'm gonna start a new one. I'll call it factoring polynomials. All right, in these first few problems here, it looks to be quite simple. Just factor out x cubed, and we'll have 6x to the 4 plus 3x minus 9. Then, now for a, it goes up to the cube, and for b, it goes up to the squared. So, b to the 6 minus 7, a to the 7, b squared plus 2, a squared, like that. Now here, the greatest common factor is 2, x squared add 1 cubed. And inside my brackets should be x minus 8 x squared add 1 squared, like that. And here, we could take out a 2 from there, and that'll be an 8x. And so we can factor out x 2 minus 6x. Like that. We'll check. Oh, you're kidding me. I didn't spot the 3. Oh. There. Okay, that's fine. Yeah, that's fine. And that's good. Here we shall factor by grouping. All right, let's do that. Factoring by grouping. Okay, well, we can factor out 7x from there, from the first two, to obtain 1 plus x squared. And then we can factor out x to the 4 from the latter pair to get 1 plus x squared. Okay, there we go. Now here, like that. Okay, good, that's correct. See? In mathematics, you get to be correct and finished. That's why it's the best. Just these first 5. There we go. I prefer to write the 6 first. Oh, we're just checking 5 at a time. Good. 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 Oh, that was a silly, silly mistake. That should have been a 3. Good. Now comes the next 4. Okay. Good. Mm-hmm. Mm-hmm. All right. Now these three. Let's see what I can do. Mm-hmm. Mm-hmm. All right, that's x to the 8 minus 256, which I guess is x to the 4 plus 16 times x to the 4 minus 16. But we notice a difference of 2 squares again. X squared plus 4, and then x squared minus 4, but it's the difference of 2 squares again. There's x plus 2, x minus 2. That's beautiful. Really, just very well designed. Oh my goodness me, look at this. A difference of 2 cubes. I actually know that pattern. I just wasn't even sufficiently animated to. Now, what is the difference of 2 cubes? X cubed minus y cubed is x minus y times x squared plus xy plus y squared, right? Really just a beautiful design. Mm-hmm. Ah, look at that. Okay. Let's see where this takes us. Oh my goodness me. Mm-hmm. Right. We'll see. Reduce each of the following to the lowest terms. So, I will factor the numerator and the denominator. if I cancel the x7, I obtain x plus 1 over x minus 3. Now, I don't know if at this stage they want to retain the information that x may not be 3 or 7, but that is something I know comes later on. Here, we notice x at 3 squared on the numerator and x at 3 times x minus 3 on the denominator. Cancelling out the x at 3, we obtain the following, and x may not be negative 3 or 3. Those are what were they called? Excluded points, something like that. There. And we'll do that. And then we'll have x squared plus x minus 20. So it can turn into that. And then we have this beautiful thing. So x may not be 4 or negative 5. And now we check. Where are we? Oh, here. Oh my dearest. No. Oh no. This is lapsing in concentration. Check the next one, make sure. Okay, it looks okay. And it is okay, and it's good. Perform the indicated operation and reduce the answer to the lowest terms. All right. What I'm going to do is factorize. If it's unfactorizable, don't waste your time. There. There. Just like that. And now we'll cancel. And then we have this beautiful result. And because they gave it in an expanded form, I'm going to reply in expanded form. Like that. So mm-hmm. Mm-hmm. Just like that. Wow. Just make sure you have pairs. Now, let's check those first two out. Ah. And, well, it appears that they did want it bracketed in the end. No harm. Mm-hmm. That's correct. Do. Okay. Okay, and down. So we just are left with those two. Beautiful. And then in problem 7, we are to divide one rational expression by another. Cancel, cancel. There you are. Nice and factored for you. Let us check. We must always check. Oh. Uh-oh. I didn't recognize that was... Oh, that's a shame. Okay, it's incomplete. Next one. And all right, so we'll just pause it there. Truly a beautiful set of notes. Oh, I really want to do these, but I should I should finish rational expressions. Anyway, be well.